Hi everyone, welcome to my YouTube channel, CC of Elections. So in this video, we'll talk about graphical procedure to perform convolution. So let's take an example. To find the convolution of the following signal by graphical method. When we say graphical method, it's just to solve or to find convolution using graphs. That's just the idea. So h of t is this, x of t is this. Now let's use graphical method. So in order to use graphical method, what you do is to let y equals everything. So the convolution of x and h is equals y. Okay, so convolution of x and h, of course, we represent them using this pattern, this convolution integral, that is x of lambda h of t minus lambda. This is shifted, and this is reversed and shifted. I said this in the previous video. So the first step is to take this guy, is to plot. This is plot, pardon my writing, this is plot x of lambda. That is, we are going to plot this part. Second step is to plot this other part, then we merge them together. That's all. Okay, so step one, let's plot this guy. So x of lambda is what? This is x of t. So anywhere you see t equals what? Lambda. So this will be e raised to the power 4 lambda. That's what we have here. U of t will be u of lambda. U of t minus 2 will be u of lambda minus 2. Okay, so this is x of lambda and this is lambda. Now unit step function, of course. Okay, unit step function. So 1 unit. Now this first line starting from 0 is what? U of lambda. That is because u lambda equals what? 0. There's no other thing here with lambda, so lambda will start from 0. Then for the other one is what? U minus 2 equals lambda, right? Is equals 0, right? So when you bring 2 to the other side, you will now have lambda equals 2. So this part from here like this going to this direction is what? U of lambda minus 2. Okay, while from 0 is just what? Lambda, and it's going from 0 to infinity. So actually this one starts from 1 and this one starts from where? Sorry, this one starts from 0 in lambda, the axis of lambda, and the x of lambda, it begins from 1 to infinity. While for this, it begins from where? 2 in lambda axis, but in the x of lambda axis, it starts from 1 to what? Infinity. So you can see that these two, x of lambda, u of lambda and u of lambda minus 2, both of them, they meet at this point. They meet at this point. Are we seeing it? Okay, so we can say the both of them together will give us what? 0 to 2. So based on the decaying exponential, 0 to 2, then we just have this box here. But based on the decaying exponential, where is the decaying exponential? That's exponential minus, that is decaying because it's negative, so it's reducing. So we'll now have it like this. Instead of having it like a square or rectangle, I'm going to have it like this with a curve because of the decaying exponential. We have plotted x of lambda. Okay, now the next step is to plot what? H of lambda. Sorry, h of lambda minus x. That should be minus t, please. Okay, not minus x, minus t. Let me make that correction quickly. Where are you? Minus t. Okay, now the next thing to do, first of all, let us identify what is h of lambda, and then what is h of lambda, and then we now identify what is h of lambda minus t. Okay, and then we'll now merge them together. Okay, so h of lambda so h of t is what? X e raised to the power minus 2t u of t. So when we talk of h of lambda, it will be what? E raised to the power minus 2 lambda u of lambda. Okay, I think that's what we have here. Exactly, that's what we have here. So lambda begins from where? Equals 0. So just start from 0. Decaying exponential, so it will just go down. Are we seeing it? Okay, minus lambda will be the opposite direction. Okay, minus lambda is the opposite direction. When you add t to it, okay, when you add t, if t is less than 0, if you add t less than 0, meaning t is negative, it will be this thing will be shifted this way. So we have it this way. So note there are 3 cases. Case where lambda is less than t. Okay, so if lambda is less than t, we have it shifted this way. Now look at it. What is this? This is x of lambda. What is this? Remember, we have done this already, saying that this is what? X of lambda. So this represents x of lambda, while this represents what? H of lambda. But h of lambda, when 3 cases now, when lambda is less than, when t is less than 0, meaning t is negative now, negative side. This is how they will look like. Okay, and this. And the second case, so there is no meeting point between the 2 signals. Okay, but in case 2, where t is greater than 0 and t is less than 2, so t is positive, is greater than 0, but it is less than 2. That means 0 is less than t, but t is less than 2. In that case, these 2 graphs will meet. So it's shifted inside. Can you see it? It's shifted inside. So you can see this is where they meet. So in this case, the integral from negative infinity to positive infinity will change to 0 to t. I mean from 0 to t. So that's what we have in 0 to t. And of course, this value and this value will be there. This is for the x of lambda, and this for what? H of lambda, h of t minus lambda. So we have here, of course, the lambda. So we just take our integral like we did in the previous video. We just simplify them. All the ones, let me do the simplification here to make things easy. Okay, so from this point you open the minus 4 lambda e raised to the power minus 2 t multiplied by plus 2 lambda d lambda. So all we did here was just 2t multiply what we have inside. 2 multiply this will give you what? Minus 2t. I should have said minus 2t. Minus 2t multiply t. Oh Jesus, what's happening, bro? Minus 2 multiply t will give you what? Minus 2t. Minus 2 multiply minus lambda will give you what? Plus 2 lambda. Okay, so of course simplify further. Minus 4 lambda e raised to the power minus 2t e raised to the power 2 lambda. Of course, now this is the meaning. Okay, this is the meaning. Now what happens next? So we are differentiating with respect to lambda, right? So all the terms that do not have lambda will go outside. They are regarded as constant. So e raised to the power minus 2t will come out. So what will be left inside is what? E raised to the power 4 lambda e raised to the power 2 lambda d lambda. I don't think I will do this in the next part, since I've done it in the previous video, and I'm doing it again, this simplification. So now of course these guys, they will come together. So you have e raised to the power minus 2t. Okay, so this will give you what? You just take one of the e and you have minus 4 lambda plus 2 lambda. That will give you what? E raised to the power minus 2 lambda d lambda. okay, which is exactly what you have at this point. So that's how we got from here to here. Okay, so of course we just take the integration. -2 will come under, that's why you have the 1 over -2. Okay, and then when this multiplies, you have here, you get this part from 0 to t. Of course the lower limit is gone because it's 0, so where you have lambda you put t. So that's how I have this. So this is for values when 0 is less than t and t is less than 2. Case 3, not 4. Why 4? Case 3, oh please. Jesus is Lord. So case 3. So in case 3, when t is greater than 2. So when t is greater than 2, you can see the t is greater than 2. This is where they meet. The range will now be 0 to 2. The range will be 0 to 2. So instead of this, negative infinity to positive infinity, the range will be from 0 to 2. So the rest things remains the same, and we are going to just do that same simplification with the previous one. Okay, so just like I simplified, the way I simplified this thing, we are doing the same simplification. However, the difference is what? The limit. That's just all. Okay, the difference is the limit. The limit is the difference. Okay, so yes. Yeah, so when we do that, we are going to have this expression. So just do the same simplification, and instead of adding, I think the second case, the limit is 0 to t, but this time it's not t, it's a value. 0 to 2, there's a value there, so not just t. Okay, yeah, in this case there is t, but this time there is 2 here, so that's why I have a value. Okay, so here we just say 0 when t is less than 0, we got 0. Look at it now. In case 1, when t is less than 0, there is no meeting point, so the answer there is 0. Then the second case, we got this when 0 is less than t but t is less than 2. The third case, we got this this when t is greater than or equal to 2. Okay, so this is the answer y of t. So if you have any question, of course, leave it in the comment section. Like, share, subscribe. This will be all for this will be all. Okay, so, and I hope this helped. Comments and share, and I'll see you when I see you. Thanks a lot for watching.